Now today we're not going to actually get to De Moivre's theorem. We're just going to get into the idea of plotting complex points and converting between polar and rectangular. Okay? Tomorrow we'll do De Moivre's theorem. One of the most powerful theorems in all of grade calc. Super amazing theorem. And I'll make a big to-do about it when we get there. Okay, so the first thing I'd like you to do is I'm going to just check your background knowledge. So I want to know if you remember how to plot a complex number. So what I'm talking about is how do you plot 2 plus 5i? Okay, this is an Algebra 2 standard, so you have learned it. If you have no idea what I'm talking about, just sit tight and wait. If you think you might know how to plot that on this xy plane, draw an xy plane and plot it right now. Okay, so first of all, don't be fooled. This is not xy graph paper. Okay? This is xiy graph paper. In other words, this is called complex graph paper. And the point 2 plus 5i should be drawn right here. 2 spaces to the right, 5 spaces up. If I can find the 5th space. Where is it? That was really bad. 5 spaces up. Okay? 2, 5. All right? So here's what's going on. Back in, 5th grade, the teacher would say, okay, class, please graph on this number line, please find 2.6. So you were like, okay, let's see, there's 1, there's 2, there's 3, right here, teacher. Okay? And it represented a point on a one-dimensional line. Okay, and then when you got into 10th grade, you studied Algebra 2, and you learned that there are some funky numbers in the world. Square root of 5 is a funky number. It fits actually right nearby here. Square root of 7 is a weird number, right? Those are irrationals. And they fit on the number line too, but there's also these square root of -1 called I, you know. Like, if I asked you, okay, hey, plot 2.6, you would plot this, right? If I said plot, square root of 5, you'd plot that green point. But if I said, okay, everybody, plot I, you'd be like, hold on, what do you mean I? I'd say, well, it's the square root of -1. And you'd say, that doesn't make any sense. And I'd say, all right, you're right. It doesn't belong on this line. This does not belong on the line. These number lines that you did back in 5th grade were real number lines. Real numbers alone, okay? All right, and then when you saw this kind of graph paper over here, it was in the context where the horizontal meant x and the vertical meant y. So you plotted things like y equals 2 minus x. And there are actually 2 numbers here, x and y. And there's like, if x is 5, then y is -3, and if x is 7, then y is -5, And they come in pairs like this, and we needed a way to represent that, so Descartes told us we could draw it like this, to represent every one of those points that obeys this rule. Right? But now we've come to a simpler question, so we're back to just plotting a single number, but where should we plot I? Where should we plot 2 plus 5i? Where do they belong? We can't put them on a number line. So the mathematicians decided, look, we have to have a way to plot this. So they created a new type of graph paper where the x represents the real numbers in the problem, namely 2, and the y's represent the imaginary numbers in the problem, namely the 5. And they said, let's just make a new graph paper where the horizontal means real and the vertical means imaginary. And we'll just plot it as 2, 5. So this is a number line. It's a one-dimensional number line. It looks 2D, but it's actually a number line. We plotted one number. This is one number, not 2 numbers. It's one number. Your brain can handle that. So it's one number that must be plotted in 2 dimensions. It's kind of like when you want to study carbon monoxide, and you know it's made of one carbon and one oxygen. Sorry? No. Yeah. Yeah. One carbon, one oxygen. But you know it's one thing, but when you look at the periodic table, you're forced to look in two places to study those elements. It's the same idea. If you want to plot this one number, you must plot it in two dimensions. You don't have a choice. So it's almost that same idea. Okay, so please think of it as one number, and these numbers are often called Z or C. Okay, so don't think, oh, Z like the third dimension. No, Z just means a number like these. 2 plus 5i, 4 plus 6i, minus rad 3 plus 6i, all right, and so forth. Okay, so if you can plot that, that's good. Let's go to the next page, and I'll have you plot a couple more. All right, so maybe you could draw a new one so it doesn't get too cluttered. I'm going to have you graph some points now. So would you please plot the following 3 points? -4 plus 2i. I will call that Z1. Let me call that Z1. And Z2. Let's do simply 5. What would that mean? And Z3. Let's make that the complex number. Somebody give me any number in the form a plus bi. Just something plus something I. 5 plus 7i. I like it. Let's just for kicks do 5 minus 7i. Take a moment and plot these, please. You'll notice that the B one is missing the I. That's meaningful, right? So that has a meaning. See if you can find these 3 points. Okay, so with the understanding that this is actually an IY axis and this is an X axis, you should have your 3 points at -4, 2. How do you plot the point Z2? There's no I mentioned, so I guess we would just have to assume it's like a plus 0i here, right? So I guess we're just going to plot the point what? 5, 0. Where does that go? On the real axis, right? And point C is Blake's point, and that's at 5, -7, so that would just be directly under it. Yeah. Okay, so we're learning a couple new things. One, we can actually plot these kinds of numbers. You're supposed to think of this as a number line, if your brain can handle that. And also, we can see that these are typically called Z1, Z2, Z3, and so on. Okay? Now, what's to stop us now from converting these to polar coordinates? We have this wonderful system called the polar world. Let's go ahead and convert all 3 of these to polar form. All the rules that you learned before for converting x's and y's to r's and thetas still apply. Okay? So let me move these out of the way. Let's look at the first one. We're going to convert to polar form. So right now what you've been given is the rectangular form, you see. This is the rectangular form. And we're going to try to convert it to the polar form. How do you do that? Well, you're going to need to know, let's do point A first, the r. R, of course, means the distance to the origin. Okay? And you're going to need to know the theta, which, of course, is the angle measured in standard position. Same old, same old. And we have formulas for this. R should just simply be the square root of -4 squared plus 2 squared. No big deal. Square root of 20. I'm not going to simplify it, okay? Just going to leave it, root 20. Theta, same old, inverse tan of y over x. Same old rule. That's the same rule we used a couple nights ago. Oh, when do I add the 180? Remember, you're supposed to add 180 on this formula, aren't you? Does anybody remember the context? Like, when do we add 180? Because my calculator is saying right now, and I'm going to go ahead and use degrees mode, guys, for today's lesson, just to help your brain. Let's use degrees mode. I'm just going to type it. What is inverse tan of negative 2/4? My calculator is saying that that angle right there is negative 26 degrees. Is that true? I don't think so. We should be adding 180 to this problem. Does anybody remember how we know to add 180?
Quadrant 2 and 3.
Quadrant 2 and 3, yes. Or you could say whenever the x that's given is negative. Right? We talked about that before. Whenever the x that's given is negative. Okay, so it wouldn't make sense anyway for this to be negative 26. I don't even believe it. So I'm going to add the 180 just out of need, and because that x is negative, and I get 153.435. So I want to remind you that if you do not have nearest thousandth from now on this year, it is wrong on my tests. Okay, and I mean for every little thing. Okay, so 3 digits after every decimal. That I believe, 153. That makes sense to me. Quadrant 2, yeah, that makes sense. Okay. All right. Are we in polar form yet? Well, we kind of know now that this root 20 is the distance from A to this pole, right? Let's just put that right there. And this angle is the angular representation of that point. So these are like the polar coordinates. But how do I write the number in polar form? Watch this. The negative 4 represents your x. I circled it there in blue, right? Remember that x is r cosine theta, isn't that true? R is root 20, you see, and theta is 153-ish. So I'm going to rewrite z1, here we go, as root 20 cosine 153.435 degrees plus, and then instead of 2i up here in purple, since that 2 represents my y, and y is r sine theta, I'm going to write root 20 sine 153.435. And I won't forget the I. So what is root 20 cosine 153.435? Why don't we check on our calculator? What is root 20 cosine 153.435? Do me a favor, type that into your calculator. You need your calculator, read it. What is your calculator? Anybody? Pen, fingers, got yours? Okay, type that for me, please. Root 20 cos 153.435. Make sure you're in degrees mode. I thought the radians would be kind of confusing today. And I said we'd use radians the rest of the year, but actually in this particular chapter they do use degrees a few times. So. What is it? Negative 4. Yeah, exactly. That's my whole point. This is negative 4. And do me a favor, type root 20 sine 153.435. Make sure you're in the degrees mode. Oh yeah, close that parentheses on the root 20. Yes. Now type root 20 sine 153.435. That's the purple there. And that's 2, right? That's my whole point, you guys. I'm saying that negative 4 plus 2i can easily be written also as root 20 cos 153 plus root 20 sine 153i. It's the same thing as 4 plus 2i. But it shows us something, right? When you look at this, you think, watch my hand. When you look at this, you think left 4 and up 2. When you look at this, you think away from the origin direction 153. It's just a different way of thinking. Okay, and then here's a couple little traditions that we have. One is these both have a root 20. So we'll pop that out. Pull out the root 20. That way we don't have to write it twice. Another tradition is we typically put the I in front of the sign, not at the back like that. Does anyone know maybe why we would want to put I sign instead of 153I? We don't want to think this angle is 153I. We want to think that this is sine 153 times I, you see. So we put I out front to prevent anyone from thinking that the angle is imaginary or something. A couple more traditions. Some people get so lazy they don't want to write cosine 153.435 plus I sine 153.435. So they've abbreviated it to write it this way. Rad 20 cis 153.435. This is the number in polar form. This is the polar form of z1 equals negative 4 plus 2i. Now, the CIS notation is not in our textbook, but you're going to be writing this so many times, you're going to wish you had an abbreviation, and here it is. Please don't forget what cis means. Okay? It means cosine 153.435 plus I sine 153 plus 0.435. I said it wrong. It means this. It's very important you know what abbreviations mean. If you can't remember that, then don't use the abbreviation, please. Don't use this if you can't remember it means this. But it is quite a bit less writing, though it really means the same. Okay, so that's point A, converted over to polar form. Can you do point B? So I will help you with point B a little bit. Point B is quite a bit easier. The y value here is 0, so this makes it quite a bit simpler to understand. So let me just replot that point. This is what you plotted, remember? Okay, so it looks like my x is 5 and my y is 0. How would you find r? Remember how I got the root 20 earlier? I'll show my work up here in red there, see it? So r is the square root of x squared plus y squared. But wait a minute, that just gives me what? This just returns 5. What does it mean? It means this point is how far away from the origin? 5. Did we really need a formula for that one? No. Okay, fine. Theta is inverse tan of y over x. Now my calculator says 0. Can I trust it? Yes, I can. Look, this point really is at what looks like the point 50 in the Cartesian world and what looks like the point 50 in the polar world. So any point that's on the x-axis like this, if there's no I, the polar representation looks very similar to the Cartesian representation. They're both at 50 in both worlds. Okay, now I'd like to construct Z2 into polar form. So Z2 should be, watch close, 5 times cosine 0 plus I, or let's just leave the 5 outside. 5 times parentheses cosine 0 degrees plus I sine 0 degrees, or the famous abbreviation CIS. 5 cis 0. Now, cis 0 is not 0. Cis 0 means cosine 0 plus I sine 0, which is actually 1. 1 plus 0. So don't just look at it and say, oh, what's cis 0? I'm going to ask my calculator. There's no cis button on the calculator. Okay? If you want to find cis 0, you have to understand it means this. And then you can ask your calculator what cosine and sine are or something. Okay? Let's try the third one. So the third one is 5 minus 7i. 5 minus 7i. This is the one Blake gave me. Okay, so identify your x and your y. Okay, class, let's work this together. So x is what? 5. Y is what? Negative 7, right? So r is going to be the square root of 25 plus what? 49. In other words, the square root of 74. Theta is going to be inverse tan of what over what? Negative 7 over 5. Add the 180 or don't add the 180? When the x is negative, correct? We add it when the x is negative. So we will not be adding 180 on this one. We'll just type it in straight up. It's even believable. Okay, so inverse tan, negative 7/5. Negative 54.462 degrees. Now we had plotted this point before because Blake had come up with it. And it was down here in quadrant. We called it point C at the time. We called it point C, and it's down here in quadrant 4. And that makes sense. Theta is negative 54. That's a perfectly valid answer. Okay, so the correct answer is, here it is, Z3 is root 74 cis negative 54.462. Now, one more small tradition. These have names. Okay? This is called the modulus, or the absolute value of Z3. So that number right there has a name. We used to call it R, but in this section it's technically called the modulus. Don't ask. Okay? And this angle, we're not really supposed to ever write a negative. You need to add 360 to it. I'm sorry, but that's just one more tradition. And therefore, this answer really should be written as root 74 cis 305.537. I'll write it here. Root 74. I can't write. It's root 75. Root 74. Cis 305.538 if you're rounding. And this has a name, this angle. You have to write it between 0 and 360. That's why I added 360. And this is called the argument. Argument. I almost lost my word there. The modulus and the argument. So we started this lesson with plotting. I'd like to end this lesson with plotting. I just want to make sure that you understand what these R cis theta type answers are and what they mean. Can you just simply plot for me in these last 2 minutes the point Z4 whose coordinates, whose polar representation is, let's just put 2 cis pi over 4. Can you graph 2 cis pi over 4 for me? If you can, then you understand what the 2 means, and you understand what the pi over 4 means. Okay, so what does the 2 mean? Meanings are important to me, right? What is that? This is your R, good. And this is your theta, also known as your modulus and your argument, right? So we are evidently out on the second ring. Kind of wish this was polar complex paper, you know? We're out on the second ring at pi over 4 right there, see? Anyone get that plot correct? Good job. Now we're going to convert it back to rectangular. If you can do this, then it means you know what cis means. So what does cis mean? It means cosine plus I sine. Cosine what? Cosine pi over 4 plus I sine pi over 4 is what it means. Don't grab your calculator. What's cosine and sine of pi over 4? Rad 2 over 2. The answer is root 2 plus I root 2. What do the rad 2's mean? It means right rad 2, up rad 2. Right rad 2, up rad 2. Those are the legs of your triangle. Awesome. Okay, so those are some early skills for 8.3. Tomorrow I'll show you how to take like z1 and z2 and multiply them, divide them, find the square root of them, and do some arithmetic with z values, z numbers. Have a good day.